Martina, and my yayo, who is a teacher, is going to teach me algebra.
Applications of exponential and logarithmic functions. Dear friends, today I am going to develop an exercise that you are going to like, because we are going to apply several properties, which have to do with the title of this video. Look. The next step. Move the expression to the left-hand side and change its sign. Move the expression to the left-hand side by adding its opposite to both sides. The sum of two opposite equals 0. Look. The next step is, write the expression in exponential form with base of 2. What is exponential form? The exponential form of an expression is as follows: it is when a is the base and b is the exponent. The given expression is written in exponential form, with the base 2 and the exponent 5. Look. The next step. To raise a product to a power, raise each factor to that power. Observe. Why raise each factor to a power? The property of raising the product to a power, state that you need to raise each factor to that same power. Now, divide both sides of the equation by 5 to the power of 2 by x. Why divide an equation? We want to divide an equation to isolate the unknown variable on one side or to transform the equation in a certain way. Both sides of the equation need to be divided by the same number to preserve the equality between the sides, according to the division property of equality. When the numerator and denominator are raised to the same power, raise the whole fraction to that power. Some of you may be wondering where that came from. This came by doing this. Watch. Like terms are terms that have the same variables raised to the same power. Express with a positive exponent. Using calculate product. When the numerator and denominator are raised to the same power, raise the whole fraction to that power. This here is the same thing I did up here. Let us continue with the exercise. With your permission, I am going to delete the entire explanation on the right, because I am going to need that space. We will now transform the equation using the following. A raised to the m, by n powers, equal, to the a, to the n power, within this parenthesis and the parenthesis raised to the power m. Watch what we are going to do. Why use substitution? Substitution is used to transform a complex equation into something simpler that we can easily solve. Example. Take for the example the following equation. First, solve the equation, using t equals open parenthesis 2/5 you close the parenthesis. With power x. Second substitute. You write, t squared, plus t, minus 1, equals, 0. We will now use the quadratic equation to solve the expression. Identify the coefficients a, b, and c of the quadratic equation. A equals 1. B equals 1. And c equals minus 1. Substitute a equals 1, b equals 1, and c equals minus 1 into the quadratic formula. I remind you of the formula. Look. Any expression multiplied by 1 stays the same. Observe the following 4 steps, write in your notebook. It is possible that if you have come this far, you liked what you are learning. Please, give me a like, subscribe and share the video with your friends, mark the bell, I will tell you when I upload a new video, for you. Let's go with the final part and the solution of this expression, which seems simple, but to solve it you have to master some skills, which it is very possible that you have forgotten. For this reason I have reminded you. As you already know, this expression has 2 solutions, a positive solution and another solution that is negative. And you are going to present them in the following way. But we are not done. Do you remember the title? Now we will substitute each one of the 2t, of the solutions, that we had with the quadratic formula. Remember that we said earlier that t, was equal to, 2/5 in parentheses with exponent x. Let us do it. Take the logarithm of both sides of the equation. The goal of taking a logarithm is to cancel the power and bring the exponent down. We need to take the logarithm of both sides because of the property of equality for logarithmic equations. How property to use the property? The property of equality for logarithmic equations states, logarithm x of base b, is equal logarithm y with base b, if and only if x equal y. In this case, we have the right side of that statement, x equal y. Because of the property, we can apply logarithm with equal bases to both sides of the equations. After that, we need to use the rule to the logarithm of b with exponent x, with base b being equal to x, to bring the variable in the exponent down. The only thing left then is to solve the new equation. Again, take the logarithm of both sides of the equation. Use logarithm of a, to exponent x, with base a, equal x, to simplify the expression. Simplifying it, we see it this way. This is the solution we are looking for, from the original expression that we had been given. Until the next video, YouTubers.